Alright guys, I'm just going to quickly walk you through the first two tests of the rock, paper, scissors kata, just to kind of give you an idea how to get started, what level of implementation I'm looking for with regards to the TDD principles. So I've created a solution, rock, paper, scissors. I've added the rock, paper, scissors test project, and you can see here the dependencies that are required to get going. So you need the test SDK, NUnit, and the NUnit 3 test adapter because we're using NUnit today. I've added a file, game test. I'm going to paste a test I have. It's not quite the right one, so we're just going to quickly make it. The correct scenario, paper versus rock. Given player has paper and opponent has rock. If you're wondering where I got the test from, it's from a final solution that I like to show people when I give this in person. I'll probably post a link to it somewhere. Cool, so now I've got the scenario. Remember, naming is the method. Scenario and outcome, so given player has paper and opponent has rock, straight from the Kata, should return player wins. Let's set about setting things up. Player equals paper, opponent equals rock, not Rick, and var sat equals new game. Why I've called it SAT is short for system under test. It's probably a naming convention that heralds from kind of the earlier days. Not everyone likes to use it, but at least it's quick to identify in a test what you're actually testing. So I've got that compilation failure I was talking about, second law of TDD, so not more than a test that's required to pass. So I was passing, now I'm failing. I'm just going to tell it to generate the type in here. That's fine. I can extract it later during a refactor phase. Okay, and then var actual equals sat dot play. And the nice thing, when the act section, I like to always name the output as actual. Player opponent, looks like I've misspelled opponent, one too many P's, dot play. Now I've got another compilation failure. I'm going to tell it to generate the method, get rid of the compilation failure. I can continue writing my test. I'm going to put the expected outcome down in the assertion and assert.r equal that the expected and the actual are the same. So no compilation failures, no red test. It's time to run the test. Control RT. We'll go to the test explorer, wait for the result. Oh, there we go. And it's always good to check why it failed. It's telling me it's not implemented. Pretty obvious, but we're strictly following the cycle of TDD, the red-green refactor. We'll be to refactoring in just a second. So what do I need to do to get this to pass? Fake it says do this dead simplest thing. In this case, it is player wins. Control RT, run the test again, and I should see this go green. Apparently I need to be in the test to run it. So there we go. Test ran, it's gone green. Let's do some refactorings. I'm going to get rid of the public constructor, make these public. Don't really have to, but it just makes me feel better, especially if I were to pull it into a different project at a later point in time. Cool, done some refactorings. Let's run the test. Always run your test after refactor. Got to make sure it's a green run before you start the next failing test. And I'm good. Yeah, everything's good. Everything's working. Now I'm going to move on to the next scenario. I'm just going to copy and paste what I have here. Look at the kata. Given player has paper and opponent has scissors. I like to start off with this kata. It allows us to really focus on the naming because it's got the scenario and the expected right there. It's a quick way to understand the rudimentary rhythms of, well, not the rudimentary, just the rhythms of TDD, the red-green refactor cycle, get into naming. It's a nice, easy way to understand how to structure your naming as well. And this one is player loses. All right, so if I run my test, and in this case, always run all your tests, I end up with an error. It's expecting player loses, but player wins. Well, what's the easiest way to make this work? I could do something like if opponent equal rock, return player loses. Okay, let's run our test. Oh. See, we didn't change our opponent, which can happen when you copy and paste tests. So I'm glad that happened. It showed us that there was a problem. Oh, sorry. And the method implementation was wrong. Okay, cool. Let's run everything, make sure it's all green. And there we go. So even if you do this a million times, you can still make mistakes. But there we go. That's kind of the idea behind fake it. If we were to, let's say, do the third, I know I said 2, but while we're on a roll, let's go. The third scenario is paper and paper. Cool. Given play given player's paper, opponent has paper, should return tie. So let's go change our expected. Let's go change. We got the arrange sorted out. So now if we run the test, we should see 2 greens and 1 red. It says player wins. I'm going to set the opponent to paper. I believe that to be the simplest thing I can do to get all 3 tests to pass. Oh, looks like it still failed. I forgot to change the return. How silly of me. Alright, should see all 3 pass now. There we go. We've got a real simple implementation thus far. Everything's green. If we felt like we could find a solution, might be time to do some refactoring, or let the Kata evolve and see where you get to. But that's kind of what I'm expecting you guys to follow. That real simple fake it implementation till you see a pattern and pull it up. All right, have fun.